In TECNOFIL, we transform copper and its alloys with the purpose of creating a planet that is more connected, clean, and efficient. We are committed to addressing the current climate crisis that our world is facing. Therefore, we strive to minimize the environmental impact of our operations and products by adopting a sustainable and environmentally friendly approach. Additionally, we value the efforts of our employees, working consistently to provide them with the best conditions for personal growth and ensuring their safety. In this way, TECNOFIL maintains its commitment to preserving our planet.
The primary objective of the project was to integrate tools for continuous quality improvement with a focus on sustainability. To achieve this goal, we employed the PDCA methodology as our guiding framework. Using this approach, we evaluated our on-site processes and identified opportunities for improvement. Subsequently, we fostered collaboration between the quality control, production, and projects departments. Furthermore, we formed a working team whose members were selected based on their technical expertise and experience. This team comprised a project leader, a specialist in continuous improvement, and 2 engineers responsible for managing liquid waste within the plant.
Our project was developed using the PDCA methodology, which stands for Plan, Do, Check, and Act. This methodology was divided into 7 steps that allowed us to progress through the project in a sequential and organized manner. In the first step, the topic was selected based on strategic objectives and local commitments of the company, including the reduction of water consumption. Then, we proceeded with step 2, which involved understanding the situation and defining the project's objective. In this step, we create a liquid waste management process diagram to understand how it relates to the different areas of the company. Additionally, we applied the brainstorming tool to map out the main issues regarding liquid waste generation in the plant, related to environmental, production, worker safety and health and economic aspects. We also gathered evidence of various identified issues, which included storing large quantities of liquid waste, production line stoppages due to the use of EPS cisterns, the use of hazardous chemical reagents in the coagulation flocculation process, and the emission of unpleasant odorous gases from certain storage tanks. On the other hand, we conducted an analysis of historical process data, through which we defined the physico-chemical characteristics of the liquid waste generated in the plant. The analyses also revealed a significant increase in liquid waste volume between 2018 and 2022, reaching 790 cubic meters in the latter year. Additionally, we noticed an increase in EPS disposal costs during the same period, totaling $31,592 in 2022. With this information, we identified the specific problem of the project, which was the increase in the final volume of liquid waste disposed of by EPS, and established the project's specific objective, to reduce the final volume of liquid waste disposed of by EPS. In the third step, we developed a work plan aiming to establish the activities and their respective timelines throughout the project. For this purpose, we utilized a Gantt chart. In step 4, which involved cause analysis, we identified the causal factors of the problem using the cause-effect diagram. The result revealed that the problem had 8 causal factors. Then, through the group nominal technique matrix, we identified the main cause of the problem, which was inadequate liquid waste treatment method. To address this primary cause, we evaluated potential solutions using the decision matrix. The result of this evaluation was that there were 2 possible methods for liquid waste treatment that could solve the problem: electrocoagulation method and evaporation method. To determine which of these 2 methods was more effective, laboratory tests were conducted using the liquid waste generated on site. The results showed that the evaporation method is the one that reduces the largest volume of liquid waste and, at the same time, produces water meeting the quality conditions for use in the processes. With these results, we proceeded to step 5 to implement the solution. In this step, we began by setting project goals, to reduce liquid waste generation by 25% and recover 50% of the water contained in the liquid waste. Afterward, we managed the procurement and installation of the evaporator equipment and its components at the plant. Upon completion of the installation, we thoroughly assessed the functionality of the components and their utilities to ensure proper operation. Next, we moved on to step 6. In this step, we evaluated the quality of the products and their applicability in the plant, determining that the distilled water recovered has 0.1% fat content and is suitable for use in the plant. Additionally, we analyzed the performance of the evaporator under different operational conditions. For this purpose, we utilized the design of experiment method with 3 factors. The results showed a mathematical model that predicts the performance of the operation. Moreover, we conducted operational modeling to estimate the process's performance in terms of recovered water, concentrated water, and unrecovered vapor. Finally, we proceeded with step 7, standardizing or implementing assurance actions. In this step, the operation of the evaporator was ensured by developing an operation instruction, training the technical staff responsible for the operation, and creating an operation record where the quantities of processed liquid waste, generated products, and the quality of the produced water are recorded.
Results. The results of the project are aligned with 3 sustainable development goals. Firstly, Goal 6, clean water and sanitation. The project reduced the use of hazardous chemicals, specifically ceasing the use of sodium hydroxide and ferric chloride. Moreover, water reuse in processes allowed TECNOFIL to decrease its annual water consumption by 448 cubic meters. Secondly, referring to Goal 8, decent work and economic growth, the project reduced the exposure time of personnel dealing with liquid waste treatment to hazardous chemicals. It also lowered the health risk index for workers from 24 to 12. Thirdly, concerning Goal 12, responsible consumption and production, the project reduced the disposal volume of liquid waste by EPS from 36.4% to 23.6%. Lastly, it's crucial to note that the project has been a success within our organization and has significantly contributed to the company's sustainable development. Thank you.